Here we have a whole bunch of instructions, but most of them boil down to get information you need in order to sketch a conic section. We're going to find the eccentricity, identify the conic, give an equation of the directrix, and then ultimately sketch. The equation that we have is r is equal to 5 over 2 minus 4 times the cosine of theta. Given the information that you know, I'd like for you to go through parts A, B, and C. So find the eccentricity, identify the conic, give an equation of the directrix. And I'd like for you to plot points associated with theta is equal to 0, pi over 2, pi, and 3 pi over 2. When you're done with all of that, come back to the video and then we'll finish it off together because there's additional considerations here with the asymptotes. So go ahead and pause it now and crank through as much as you can. Well, I've taken this as far as I asked you to get it. Because we had a leading coefficient in the denominator of 2, I divided numerator and denominator by 2. We get r equals 5 halves divided by 1 minus 2 times the cosine of theta. Since e is 2, we know that we have a hyperbola. In the numerator, we have 5 halves, that's ed. Since 5 halves is equal to ed and e is equal to 2, by dividing by 2, we get that d is 5/4. Having a cosine term in the denominator means that our directrix is vertically oriented. And with a minus sign in the denominator, we know that directrix has an equation of x equals the negative of the value we got for d, and so x equals negative 5/4. Going back to the original equation, r equals 5 over 2 minus 4 times the cosine of theta. When theta is equal to 0, I have a radius of negative 5 halves. I have a radius of 5 halves also when theta is equal to pi over 2 and when theta is equal to 3 pi over 2. When theta is equal to pi, we have a radius of 5/6. And so I've plotted these. 0, negative 5 halves is not going to be on the positive x-axis, but on the negative because of the negative radius. And then on the positive y-axis and the negative y-axis, we have a radius of 5 halves. And then finally, on the negative x-axis, we have a radius of 5/6. That's as far as I asked you to take this because, I mean, how do you connect these dots? Well, we don't. We only connect a few at a time. This is a hyperbola, and so it's going to have 2 branches. Considering the original equation here, we know that r is undefined when when 2 minus 4 times the cosine of theta is equal to 0 from the denominator. That means when the cosine of theta is equal to 1/2, or when theta is equal to pi over 3 or 5 pi over 3. Our asymptotes will be parallel to these lines. We weren't asked to come up with the center, but let's go ahead and do that because it'll help us deal with the asymptotes. The center is going to be on the x-axis, and it's going to have an x-coordinate that is the average of the x-coordinates of the 2 vertices here. The x-coordinates of the 2 vertices are negative 5 halves and negative 5/6. Averaging those, we get negative 5 halves minus 5/6 divided by 2. You can verify the arithmetic gives us an x-coordinate for the center of negative 5/3. So that's going to be 1/2, 1, 1.5. Negative 1 2/3 is going to land somewhere around here. So there's our center. All right, let's go back to these lines. Theta equals pi over 3 and theta equals 5 pi over 3. Theta equals pi over 3 is associated, maybe in our heads, with 60 degrees. So we have that line there. And then 5 pi over 3 is going to be that line there associated with negative 60 degrees, if you like. But these are in the wrong place. These asymptotes are supposed to intersect at the center. We know that from our previous work with conic sections. So I'm just going to move these asymptotes to intersect at the center. And now I'm ready to draw the branches of the hyperbola. They start at the vertex, they go out to one of the points that we plotted, and then become asymptotic with these asymptotes. And there we have it.